For most of human history, the universe has sent objects through our solar system without anyone ever noticing. But in our time, one of them finally did not pass unseen. 3I at Atlas was not loud. It did not explode or flare brightly in the sky. It appeared quietly as a small anomaly in astronomical data, moving a little too fast, coming from a direction that did not belong to our sun. And almost immediately, scientists asked a very simple question: how rare is an object like this really? To understand that question, we first need to slow down. Because in a universe measured in billions of years and trillions of kilometers, the word rare does not mean what it means to us. 3I Atlas is an interstellar visitor. It was not born here. It formed around another star in another planetary system long before Earth ever existed, and has been drifting through interstellar space ever since. The fact that it crossed our solar system at all was not guaranteed. A tiny change in direction, a slight difference in timing, and it would have passed through the galaxy without ever being seen. So when we ask how rare an object like 3I Atlas is, we are not only asking about numbers, we are asking about probability, timing, and the limits of what humans are able to observe. Tonight, we are not here to rush toward answers. We are here to understand what rarity means when the universe itself is unimaginably vast. And as 3I RAR Atlas continues its quiet journey through our solar system, it invites us to consider a deeper question. Not just how rare it is, but how many similar travelers may have passed by before, unnoticed, in the long silence of space. In astronomy, the word rare has a meaning that is often misunderstood. Outside of science, rare usually implies something unique, almost mythical, something that exists only once. But in the calm language of astronomy, rare does not mean one of a kind. It means something else entirely. In scientific terms, rare refers to frequency. How often something is observed within the limits of our instruments, our time, and our position in the universe. An object can be extremely common in reality, and still be considered rare if we only see it once or twice. This distinction matters, because astronomy is not the study of everything that exists. It is the study of what passes through our narrow window of observation. Telescopes do not scan the universe continuously in every direction. They look at specific regions at specific times with specific sensitivities. They are limited by Earth's rotation, by weather, by funding, by human attention. Even space-based observatories follow schedules and priorities. So when astronomers describe an object like 3I Atlas as rare, they are not claiming it is unusual in the universe as a whole. They are saying it is unusual within our experience of observation. Numbers whisper more than they speak. From a statistical perspective, rarity is shaped by detection. If something moves quickly, reflects little light, or travels through regions we are not watching, it may never be seen. If it passes through the solar system at a time when no telescope is pointed in the right direction, it simply goes unnoticed. Astronomy, in this sense, is deeply dependent on timing. Not just cosmic timing, but human timing. Space rarely gives us simple answers. Consider how many objects may pass through interstellar space at any given moment. Current models suggest that interstellar debris, fragments from planet formation around other stars, could be abundant. They drift silently between systems, carrying the chemical memory of places far away. Yet only a tiny fraction of them will ever cross paths with our solar system. And an even smaller fraction will do so in a way we can detect. This creates a subtle paradox. The more we learn about the universe, the more we realize how incomplete our view truly is. Silence is also a kind of data. For every object we observe, there may be countless others that remain invisible. Not because they are hiding, but because no one is looking at the right place at the right moment with the right tools. Astronomers often speak about observational bias. This is the idea that what we detect is shaped by how we look. Bright objects are easier to find than dark ones. Slow objects are easier to track than fast ones. Nearby objects are easier to study than distant travelers. As a result, our catalogues of the universe are not neutral inventories. They are reflections of our limitations. When we say an object is rare, we are often saying something about ourselves. How many objects have passed through the outer edges of the solar system without being recorded? How many have crossed inside planetary orbits, leaving no trace? How many have brushed past Earth's neighborhood while humanity slept, unaware? These are not dramatic questions, they are quiet ones. They sit in the background of astronomical research, shaping how scientists interpret every discovery. There is a certain humility built into this process. Astronomy does not assume completeness, it assumes absence. In this way, the science itself carries a philosophical weight. In human life, rarity works in a similar way. We often label things as rare because we encounter them infrequently. A meaningful conversation, a moment of deep calm, a sense of clarity that arrives without effort. But are these experiences truly uncommon? Or do they simply pass through our lives while our attention is elsewhere? Just as telescopes miss objects outside their field of view, people miss moments that fall outside their focus. We are busy, we are distracted, we are pointed in another direction. And so we conclude that something is rare when it may simply be unnoticed. Space offers a quiet mirror here. It reminds us that absence of evidence is not evidence of absence. That invisibility is often a matter of perspective, not existence. Numbers whisper more than they speak. Astronomers understand this deeply. Every new detection carries both excitement and restraint. It is not a declaration of final truth, but an invitation to refine models, to question assumptions, to listen more carefully. The universe does not rush to reveal itself. It offers fragments, glimpses, partial stories, and perhaps that is why discoveries like 3I Atlas feel meaningful without being dramatic. They do not shout. They appear quietly, asking us to reconsider what we think we know about frequency, chance, and presence. Space rarely gives us simple answers. In the end, the concept of rarity in astronomy teaches a gentle lesson. What we observe is shaped by when we look, how we look, and whether we are prepared to notice at all. And as we continue to scan the skies slowly and patiently, we may find that what once felt rare was never truly scarce. It was simply waiting, moving through the dark, until our attention finally crossed its path. When astronomers speak about interstellar objects today, they often begin with a short list of names. Not because there are many, but because there are so few that each one reshaped our understanding. The first was Oumuamua. Detected in 2017, it appeared unexpectedly, already on its way out of the solar system. Its path was unusual. Its speed was too high to be gravitationally bound to the Sun. Its trajectory pointed clearly to an origin beyond our planetary neighborhood. Soon after, in 2019, came 2I Borisov. Unlike Oumuamua, Borisov behaved more like a familiar comet. It showed a visible coma. It released gas and dust in ways astronomers recognized. But its orbit told the same story. It came from elsewhere. These two objects quietly introduced a new category in astronomy. Visitors not formed around our Sun. Fragments of other planetary systems passing briefly through ours. Now enters 3I Atlas. It is important to state this clearly. 3I Atlas is not the first interstellar object ever detected, but it is different enough to deserve careful attention. Oumuamua followed a highly hyperbolic trajectory, moving rapidly and leaving before astronomers could fully characterize it. Its velocity was extreme, its shape inferred only indirectly, its behavior puzzling. It did not show the clear signs of outgassing that comets usually display. This absence of familiar features raised questions that remain unresolved. 2I, Borisov, by contrast, felt almost comforting to scientists. Its orbit was interstellar, but its chemistry and activity resembled comets from our own solar system. It released carbon monoxide, water, and dust. It followed known physical rules. It suggested that other star systems might produce objects similar to our own. Numbers whisper more than they speak. 3I. Atlas sits somewhere between these two experiences. Its trajectory confirms an interstellar origin without ambiguity. Its velocity places it firmly outside the Sun's gravitational family. But its composition and behavior do not align perfectly with either of its predecessors. Compared to Oumuamua, 3I Atlas appears more chemically expressive. Compared to Borisov, its signatures suggest differences in formation conditions. Its motion through the solar system is precise, fast, and transient. It does not linger. It passes through, offering a narrow window of observation. This is what makes it significant, not because it is unprecedented, but because it adds contrast. Astronomy advances not by isolated discoveries, but by comparison. One object is an anomaly. 3 objects begin to form a pattern. Space rarely gives us simple answers. The deeper question, however, is not just what these objects are, but why they were only discovered so recently. Interstellar objects have likely been passing through the solar system for billions of years. Long before telescopes, long before humans, long before Earth itself took its current form. So why the 21st century? The answer lies not in space, but in us. Modern sky surveys continuously scan large portions of the sky. They detect faint, fast-moving points of light that older instruments would have missed. Automated algorithms flag unusual trajectories within hours. Global networks of observatories share data almost instantly. This level of sensitivity did not exist before. Earlier generations of astronomers relied on manual observation, photographic plates, and limited coverage. Fast interstellar visitors would have passed unnoticed, blending into the background. Silence is also a kind of data. For centuries, the absence of detections was not proof that interstellar objects were rare. It was simply a reflection of observational limits. This raises a quiet but profound possibility. These objects may not be new at all. What is new is our ability to see them. Astronomy often advances this way. Not through sudden changes in the universe, but through gradual refinement of perception. The stars do not rearrange themselves when technology improves. Our understanding does. Numbers whisper more than they speak. When knowledge expands, it can feel as though reality itself is changing. But the universe remains steady. It is our map of it that grows more detailed. This realization carries a philosophical weight. Human progress does not create new cosmic phenomena, it reveals them. The solar system did not suddenly become porous to interstellar visitors in recent years. It always was. What changed was our readiness to notice. In this sense, discoveries like Oumuamua, Borisov, and 3I Atlas are not disruptions, they are reminders. They remind us that the universe operates on scales far beyond human awareness. That much of reality unfolds quietly, without announcement. Space rarely gives us simple answers. There is humility embedded in this truth. Scientific advancement does not place humanity at the center of the cosmos. It gently moves us further from it. Each new detection expands the boundary of what we know, while simultaneously revealing how much remains unseen. 3I Atlas is part of that process. Not an isolated mystery, but a continuation of a larger story. A story about motion, chance, and perspective. As more interstellar objects are detected in the future, they will likely seem less surprising. Patterns will emerge. Models will refine. The unknown will slowly become familiar. And yet, something essential will remain unchanged. The universe will not feel smaller, only more visible. In the end, the significance of these discoveries may not lie in their rarity, but in what they reveal about human perception. Knowledge does not add new objects to space. It opens our eyes to what was already there, moving silently through the dark, long before we learned how to look. When scientists speak about the probability of an interstellar object crossing our solar system, they are not talking about a single number. They are describing a quiet intersection of geometry, motion, and time. Space is vast beyond everyday intuition. Stars are separated by distances so large that even objects traveling for millions of years may never come close to another system. For an interstellar object to pass through the region influenced by our Sun, its trajectory must align with a very specific spatial corridor. This is not about aim or intention, it is about geometry. Imagine the solar system as a thin, rotating plane carved through space. Most planets orbit within this plane, known as the ecliptic. It is not a wide target. It is a narrow disk compared to the surrounding volume of interstellar space. An object approaching from another star system can come from any direction, above the plane, below it, at steep angles or shallow ones. Only a small fraction of those paths intersect the region where we are actively observing. Numbers whisper more than they speak. Probability in this context is shaped by alignment. A slight change in angle can mean the difference between a detectable passage and complete invisibility. If the trajectory is tilted just a few degrees differently, the object may pass far above the planetary plane, never approaching the inner solar system. Time adds another layer. The solar system is not standing still. It moves around the center of the galaxy. The Sun carries its gravitational influence through space like a quiet wake. For an interstellar object to cross this moving target, its arrival must coincide precisely with where the solar system happens to be at that moment. This overlap of paths is brief. Even when alignment occurs, the window for observation is narrow. Interstellar objects move fast. Their velocities relative to the Sun are often much higher than objects bound to the solar system. They arrive, pass through, and depart quickly. Space rarely gives us simple answers. Gravity then complicates the picture further. Jupiter plays a silent but powerful role. As the most massive planet in the solar system, it acts as a gravitational gatekeeper. Its presence can bend trajectories, accelerate objects, or deflect them entirely. In some cases, Jupiter's gravity can pull an interstellar object slightly inward, bringing it closer to the inner solar system where detection becomes possible. In others, it can sling the object away before it ever comes close. This influence is subtle. It depends on timing, distance, and approach angle. A difference of a few thousand kilometers at closest approach can change the outcome completely. Silence is also a kind of data. The fact that we detect so few interstellar objects tells us something important. It suggests not that they are absent, but that the conditions required for detection are rare. The object must cross the solar system at the right angle, at the right speed, at the right moment. And it must do so while our instruments are watching. 3i Atlas met all of these conditions, but it did not do so by necessity. It did so by chance. A slightly faster velocity, and it would have spent less time within observable range. A slightly different angle, and it would have passed outside the regions we monitor most carefully. A small shift in timing, and it would have crossed decades earlier or later unnoticed. Numbers whisper more than they speak. This is where probability becomes almost philosophical. From a cosmic perspective, there is nothing remarkable about an interstellar object drifting through space. What is remarkable is the overlap between its path and our awareness. Astronomy often reminds us that observation is not guaranteed. It is conditional. The universe does not adjust itself to be seen. We happen to be present when certain events unfold. Space rarely gives us simple answers. This idea carries a quiet resonance beyond science. In human life, many moments exist for the same reason. Not because they were inevitable, but because circumstances aligned just enough. A conversation happens because two people arrive at the same place at the same time. A decision changes a life because it is made under a specific set of conditions. A relationship begins because of a minor deviation from routine, a few seconds earlier or later, and the moment dissolves. Just as with interstellar trajectories, these moments are shaped by geometry and timing. Paths cross, speeds differ, outcomes change. Silence is also a kind of data. We rarely think about the countless moments that did not occur, the meetings that almost happened, the opportunities that passed just outside our awareness. They leave no record, much like interstellar objects that never enter our observational window. And yet, they are part of the same structure of chance. 3i Atlas reminds us of this gently. Its presence is not a declaration, it is a coincidence made visible. Astronomy does not frame this as destiny or meaning, it frames it as probability. But within that probability lies something quietly human. An appreciation for how much of existence depends on small deviations. Numbers whisper more than they speak. When we look at the path of 3i Atlas, we are not witnessing a rare object alone. We are witnessing a rare alignment between motion and attention. The universe did not send it to us, it simply passed by. We were here to notice, and perhaps that is enough. Because in both space and life, many of the moments we remember exist not because they were meant to happen, but because they happened to cross our path briefly before continuing on into the dark. Modern astronomical models suggest something that feels quietly counterintuitive. Interstellar objects may not be rare at all. In fact, when scientists simulate how planetary systems form and evolve, they find that vast numbers of small bodies are routinely ejected into interstellar space. During the early stages of a star's life, planets shift, migrate, and sometimes collide. These movements scatter debris. Asteroids, comet-like fragments, and rocky remnants are thrown outward, escaping the gravity of their home stars. Over billions of years, this process repeats across the galaxy. Every star system contributes its share. The result is a slow, continuous population of wandering material moving between stars. Numbers whisper more than they speak. From this perspective, interstellar space is not empty. It is filled with quiet travelers, most of them small, dark, and cold. They do not announce themselves, they reflect little light, they follow no predictable paths from our point of view. If this is true, then the presence of objects like 3i Atlas is not extraordinary in itself. What is extraordinary is that we notice them at all. The central challenge is detection. Modern telescopes are powerful, but they still operate within limits. They search for moving points of light against a dense background of stars and galaxies. They prioritize certain regions of the sky. They rely on algorithms trained to recognize expected patterns. Interstellar objects break those expectations. They arrive from unusual directions. They move at unfamiliar speeds. They may brighten or fade unpredictably. Silence is also a kind of data. Because of this, most interstellar objects pass through the solar system unnoticed. They are too faint. They move too fast. They arrive at times when the sky is not being watched closely. Detection, then, is not about abundance. It is about alignment between object and observer. Space rarely gives us simple answers. This leads to a quiet puzzle. If interstellar objects are common, why does each confirmed detection feel disruptive? Why does it generate headlines, papers, and speculation? Part of the answer lies in human psychology. We are drawn to what challenges our categories. For centuries, the solar system was understood as a closed family. Objects belonged here, or they did not. Interstellar visitors blur that boundary. Each detection forces a shift in perspective. It reminds us that the solar system is not isolated. It is porous. Another reason is scarcity of data. With only a few confirmed examples, every new object carries disproportionate weight. It is asked to answer questions it cannot possibly resolve on its own. Numbers whisper more than they speak. In science, patterns require repetition. One event is interesting. Several events suggest a trend. Many events allow understanding. We are still at the earliest stage. This early stage is naturally accompanied by attention. Not because the objects are rare, but because our familiarity with them is. Silence is also a kind of data. There is an important distinction here. Something can be statistically common and experientially rare at the same time. Air is common, yet a sudden change in air pressure is immediately noticeable. Water covers most of Earth, yet fresh water in the desert feels extraordinary. Interstellar objects may occupy a similar category. They exist in large numbers, but their interaction with our awareness is infrequent. This tension between presence and perception shapes how we talk about rarity. Space rarely gives us simple answers. The philosophical implication is subtle. When we label something as rare, we are often expressing unfamiliarity rather than true scarcity. We are responding to the limits of our experience. This happens far beyond astronomy. In daily life, we describe moments of stillness as rare, not because they do not occur, but because we rarely stop long enough to notice them. We call genuine attention rare. We call deep listening rare. Perhaps these things are not scarce at all. Perhaps they simply fall outside our habitual focus. Interstellar objects invite the same reconsideration. They have likely passed through the solar system long before humanity existed. They will continue long after. Their presence does not depend on us. What depends on us is recognition. Numbers whisper more than they speak. As detection methods improve, interstellar objects will likely become less surprising. Not because they change, but because our expectations do. The shock of discovery will fade into routine observation. The unfamiliar will become catalogued. The extraordinary will become normal. And when that happens, the universe will not feel diminished. It will feel more continuous. This is how science often progresses, not through sudden revelations, but through gradual normalization. We adjust our sense of what is possible. In that adjustment lies a quiet lesson. Rarity is not always a property of the world. Sometimes it is a property of attention. 3i Atlas does not ask to be exceptional. It simply passes through, indifferent to how we label it. What changes is not the object, but our relationship to it. And perhaps the most lasting shift is this. As our awareness expands, what once felt rare may reveal itself as something we were simply not yet accustomed to seeing. When astronomers began to analyze the composition of 3i Atlas, they approached it with caution rather than expectation. Chemical signatures do not speak loudly. They appear slowly, as patterns in light, requiring patience to interpret. At first glance, the object behaved in ways that felt familiar. As it traveled closer to the sun, subtle signs of activity appeared. Gas was released, dust followed. These are behaviors commonly associated with comets. Yet, familiarity in astronomy is never complete. Comets from our own solar system are well studied. They are remnants from its early formation, composed largely of frozen water, carbon dioxide, carbon monoxide, and simple organic compounds. As sunlight warms them, these ices sublimate, forming a surrounding cloud called a coma and sometimes a tail. 3i Atlas shares part of this behavior. It releases gas as it warms. It carries volatile materials that respond to solar radiation. In this sense, it resembles an ordinary comet. Numbers whisper more than they speak. The differences emerge when scientists look more closely. The relative proportions of gases matter. The balance between water, carbon-based molecules, and trace elements carries information about where and how the object formed. Early observations suggested combinations that did not perfectly match the patterns seen in most solar system comets. Not radically different, not inexplicable, but distinct enough to be noticed. This is what drew attention. Astronomers are trained to recognize ranges. They know that no two comets are identical. Variation is expected. Yet 3I Atlas appeared to sit near the edges of familiar distributions. Some gases appeared more prominent than expected. Others were comparatively subdued. The dust-to-gas ratio hinted at formation conditions unlike those typical near our Sun. Space rarely gives us simple answers. These observations do not point to something artificial or extraordinary. They point to difference. And in astronomy, difference is often a quiet clue rather than a conclusion. The chemistry of an object reflects its birthplace. Temperature, pressure, radiation, and time all leave traces. A comet forming around another star experiences a different environment, different stellar radiation, different disk chemistry, different histories of collision and movement. Silence is also a kind of data. What scientists did not see was just as important as what they did. There were no clear signs of processes that defy known physics. No single compound stood out as impossible. No behavior demanded an exotic explanation. Instead, the data suggested a familiar story told with a different accent. 3I. The atlas does not break chemical rules. It follows them under conditions we do not experience locally. Numbers whisper more than they speak. This distinction matters because it shapes how science proceeds. Astronomy does not rush to label the unknown as anomalous. It catalogues, compares, and weights. Unusual does not mean unprecedented. Different does not mean intentional. There is a tendency, outside of science, to search for purpose in variation, to assume that difference implies design or meaning. Nature does not operate this way. In natural systems, variation is a consequence, not a goal. Two planets form under slightly different conditions and become distinct worlds. Two comets condense at different distances from their stars and carry different chemical signatures. No intention is required. Space rarely gives us simple answers. This perspective invites a quieter form of wonder. Not the wonder of surprise, but the wonder of consistency across difference. The laws of physics apply everywhere. What changes are the initial conditions. 3I. Atlas is a product of another stellar neighborhood. Its chemistry is a record of that environment, not a message, not a mystery demanding interpretation. Just a history written in molecules. Silence is also a kind of data. In this way, the object teaches a restrained lesson. It reminds us that diversity in nature does not need justification. It emerges naturally wherever conditions vary. The same is true closer to home. On Earth, ecosystems differ not because they aim to, but because climates, soils, and histories differ. In human lives, people diverge not because difference is required, but because circumstances shape outcomes. Numbers whisper more than they speak. When scientists study the composition of 3I Atlas, they are not searching for meaning. They are searching for context. What kind of star did it orbit? At what distance did it form? How cold was its original environment? How long did it drift before arriving here? Each molecule contributes a small piece of that story. None of them shout. Space rarely gives us simple answers. And perhaps that is the deeper philosophical resonance of this chapter. Difference does not always carry intention. It does not always point to significance beyond itself. Sometimes, it simply reflects the quiet diversity of conditions across the universe. 3I Atlas is not asking to be explained as exceptional. It is asking to be understood as specific. As our instruments improve and more interstellar objects are studied, this perspective will deepen. Patterns will emerge. Variations will settle into broader families. What feels unfamiliar now will become part of a larger map. Until then, each object offers a gentle reminder. Nature does not strive for uniformity. It produces difference wherever circumstances allow. And in that difference there is no message to decode. Only a quiet record of how many ways matter can come together, drift apart, and briefly pass through our awareness before continuing on its way. When scientists consider how long 3I Atlas has been traveling through interstellar space, they begin with uncertainty rather than numbers. There is no starting timestamp etched into the object. There is no record of its departure. Only motion, direction, and physics offer quiet clues. Based on its velocity and trajectory, 3I Atlas was not formed near our Sun. It was shaped around another star, likely during the early stages of that system's formation. At some point, gravitational interactions altered its path. A planet shifted, a close encounter occurred, and the object was released into interstellar space. From that moment, it began a journey without a map. Numbers whisper more than they speak. Astronomers can estimate minimum travel times. Even conservative models suggest that 3I Atlas has been drifting for millions of years, possibly tens of millions, perhaps longer. To place that in context, Earth is about 4.5 billion years old. Life on its surface has existed for a little over 3.5 billion years. Modern humans have been here for roughly 300,000 years. Recorded history covers only a few thousand. Against these scales, the journey of 3I Atlas stretches quietly beyond human intuition. Space rarely gives us simple answers. If the object has traveled for tens of millions of years, it began its journey long before the first humans appeared, long before cities, long before language. It may have been moving between stars while Earth was still reshaping its continents, and during all that time, there was no one watching. Silence is also a kind of data. Interstellar space is not a corridor with destinations. It is a vast environment where motion continues unless interrupted. Objects do not travel towards something. They simply persist. 3I Atlas does not carry intention. It does not aim. It does not search. It drifts. This is what makes its journey difficult to imagine. We are accustomed to travel having purpose. Origins and destinations, departures and arrivals. Interstellar motion does not follow that structure. The object may never have been meant to encounter another star again. It could have wandered indefinitely, passing through the galaxy without interaction. Its encounter with our solar system was not a goal. It was a coincidence. Numbers whisper more than they speak. From a scientific perspective, this challenges how we think about time. We measure time in cycles, days, years, lifetimes. But interstellar objects exist on scales where these units lose meaning. Millions of years pass without event. Nothing marks the passage. No observer counts the intervals. Space rarely gives us simple answers. There is something quietly unsettling about this. Not in a dramatic sense, but in a reflective one. We tend to associate existence with observation. If something happens, someone notices. If time passes, someone remembers. But most of the universe exists without witnesses. 3I Atlas spent the vast majority of its existence unseen, not ignored, simply unobserved. Silence is also a kind of data. This silence does not diminish its reality. If anything, it reinforces it. The universe does not require attention to function. Stars form and fade. Galaxies collide. Objects travel immense distances without recognition. Human awareness occupies only a narrow slice of cosmic time. Numbers whisper more than they speak. This contrast invites a philosophical pause. Humans live inside time. We experience it as movement, as urgency, as loss and anticipation. We remember the past, we plan for the future, we feel time pressing. The universe does not experience time this way. It does not hurry, it does not delay, it does not reflect. It simply unfolds. 3i Atlas embodies this difference. Its journey has no emotional arc, no beginning or ending that matters to it, only motion governed by physics. Space rarely gives us simple answers, and yet, when we encounter such an object, we cannot help but frame it within our own sense of time. We ask how long it has traveled, where it came from, what it has witnessed. These questions say more about us than about the object. We seek narrative. The universe offers continuity. Silence is also a kind of data. From another perspective, the age of 3i Atlas highlights something subtle. The present moment is extraordinarily brief. The fact that humans exist at the same time this object passes through our solar system is statistically insignificant. And yet, it is everything to us. Our instruments happen to be ready. Our surveys happen to be running. Our attention happens to be aligned. Numbers whisper more than they speak. This overlap does not grant meaning to the object. It grants meaning to the moment. Science does not interpret this as fate or design. It interprets it as timing, a rare convergence between motion and observation. Space rarely gives us simple answers. In this way, 3i Atlas becomes a quiet reference point, not for drama, not for speculation, but for scale. It reminds us that most of existence unfolds outside human time. That much of reality does not intersect with awareness at all. And when it does, briefly, it invites reflection rather than conclusion. The object will continue its journey. It will leave the solar system. It will return to interstellar space. And once again, it will travel without witnesses. Humans will continue to measure time in moments, years, and lives. The universe will continue to move through time without noticing the difference. And perhaps that contrast is the most enduring lesson of all. When scientists discuss the scientific value of 3i Atlas, they rarely begin with excitement. They begin with restraint. The object itself is small. It does not alter planetary orbits. It does not threaten Earth. It does not transform physics. And yet, its value is real. Not because it changes what we know, but because it quietly refines it. At its core, 3i Atlas is a data point from another star system. That alone is rare in practice, even if such objects are common in theory. Most of what we know about planet formation comes from indirect observation. We study disks of gas around young stars. We model collisions. We simulate gravitational chaos. But these are reconstructions. 3i Atlas is physical evidence. Numbers whisper more than they speak. Its trajectory confirms that planetary systems do not simply keep what they form. They lose material. They eject it. Planets migrate, interact, and scatter debris outward into interstellar space. This supports modern models suggesting that planetary systems are dynamic and often unstable in their early stages. Small bodies are routinely expelled as planets settle into long-term orbits. The chemistry of 3i Atlas adds another layer. Its composition offers clues about temperature gradients, radiation environments, and chemical pathways in a system not our own. It is not a complete picture, but it is a sample, a fragment of another history. Space rarely gives us simple answers. Each molecule detected in its coma becomes a constraint on theory, not a conclusion, but a boundary. Models that cannot produce such compositions must be adjusted, those that can gain quiet support. This is how science advances, slowly, incrementally. Silence is also a kind of data. Even what 3i Atlas does not show matters. The absence of certain compounds narrows possibilities. The lack of extreme behavior reinforces known physics rather than challenging it. This is not a failure of imagination. It is a strength of method. Scientific value is not measured by surprise alone. It is measured by consistency with evidence. Numbers whisper more than they speak. From a technical perspective, objects like 3i Atlas help answer a long-standing question. Are the processes that formed our solar system common or unusual? So far, the answer leans toward common. Planetary systems elsewhere appear to follow similar physical rules. They form disks, they build planets, they scatter leftovers. This does not make the universe less interesting. It makes it more coherent. Space rarely gives us simple answers. Yet despite this quiet scientific framing, discoveries like 3i Atlas often resonate far beyond research papers. They appear in headlines. They capture attention. This response is not driven by technical importance alone. There is something about interstellar visitors that reaches deeper. Perhaps it is because they come from elsewhere. They are reminders that the solar system is not sealed, that Earth is not enclosed in a cosmic bubble. They pass through without regard for us. Silence is also a kind of data. Human emotion responds strongly to this idea, not out of fear but out of perspective. A small object drifting through space does not matter in a practical sense, but it challenges an old intuition, the intuition that we are central, that our system is self-contained. 3i Atlas quietly disagrees. Numbers whisper more than they speak. It does not announce itself as important. It does not ask for attention. It simply exists, briefly intersecting with our awareness before moving on. This is often how the universe communicates, not through spectacle, but through scale. Space rarely gives us simple answers. Philosophically, this touches something fundamental. Human cultures have long placed themselves at the center of meaning, the center of creation, the center of purpose. Science has been slowly, patiently undoing this assumption. First, by showing that Earth is not the center of the solar system. Then that the solar system is not the center of the galaxy. Then that the galaxy is one among billions. Interstellar objects extend this pattern. They show that even the materials passing through our neighborhood did not originate here. We are not the source. We are not the destination. We are a crossing point. Silence is also a kind of data. This realization does not diminish human experience. It reframes it. If we are not central, then meaning is not assigned by position. It is created by awareness. 3i Atlas does not matter because it is important. It matters because it reminds us of proportion. Our lives unfold on a narrow slice of time and space. Yet within that slice, we ask questions that reach far beyond it. Numbers whisper more than they speak. The scientific value of 3i Atlas will likely increase slowly over time. As more interstellar objects are detected, patterns will emerge, comparisons will sharpen, models will mature. One object alone does not rewrite theory. Many objects refine it. This patience is central to science. Space rarely gives us simple answers. In the meantime, the emotional response remains, not because the object demands it, but because it invites reflection. It invites us to see ourselves as participants rather than anchors, observers rather than owners. 3i Atlas will leave the solar system. Its data will remain, its presence will fade into records and models. What endures is the shift in perspective, that we are part of a much larger flow of matter and motion, that things pass through without concern for our narratives, and that understanding does not require importance. Sometimes, the most meaningful discoveries are not those that place us at the center of the story, but those that gently remind us that we never were. When astronomers describe 3i Atlas as rare, they are not pointing to a single cause, they are referring to a convergence. Rarity, in this case, is not a property of the object alone. It emerges from several quiet factors aligning at once. First, there is origin. 3i Atlas did not form around our Sun. It carries the signature of another stellar system, shaped by conditions we do not directly experience here. That alone places it outside the ordinary population of objects we study. Second, there is trajectory. Its path intersected the solar system at a precise angle. crossing regions where our instruments could detect it. A small change in direction, and it would have remained invisible. Third, there is timing. It arrived during an era when wide-field sky surveys were active, automated, and attentive to fast-moving anomalies. A century earlier, it would have passed unnoticed. A century later, it might have been catalogued as routine. Fourth, there is behavior. Its motion, speed, and chemical expression differed subtly from familiar solar system comets. Not enough to defy physics, but enough to stand out against expectation. None of these factors alone make it rare. Together they do. Numbers whisper more than they speak. This is how science often uses the word rare, not as a statement of uniqueness, but as a description of low probability overlap. An object like 3I Atlas may exist many times across the galaxy, but the chance of one passing here now, in a detectable way, is small. Space rarely gives us simple answers. This distinction is important because it shifts how we interpret significance. Rarity does not automatically imply importance, it implies context. A solar eclipse is rare at a specific location, but common on a planetary scale. A comet visible to the naked eye feels extraordinary, even though comets are abundant. Rarity is often local. Silence is also a kind of data. When we step away from science and move toward philosophy, the idea of rarity becomes even more subtle. Does something rare need meaning, or does meaning arise only when someone notices it? In nature, objects exist regardless of observation. Mountains erode, rivers flow, stars burn and fade. None of this requires interpretation. 3I Atlas did not become rare because humans observed it. It simply followed its path. What changed was awareness. Numbers whisper more than they speak. Human meaning does not exist in isolation from perception. We assign significance through attention, through comparison, through memory. A stone on a beach is ordinary. The same stone, noticed and kept, becomes meaningful. Not because it changed, but because we did. Space rarely gives us simple answers. This raises a quiet question. If 3I Atlas had passed through the solar system before telescopes existed, would it have been rare? Scientifically, yes. Experientially, no. Rarity without awareness leaves no trace. Silence is also a kind of data. In this way, rarity and meaning are not the same thing. Rarity describes probability. Meaning describes relationship. Science is careful to separate these. It measures frequency. It avoids intention. Philosophy steps into the space science leaves open. It asks why certain discoveries resonate emotionally even when their practical impact is small. 3I Atlas does not change daily life. It does not alter climate, technology, or survival. Yet, it draws attention. Perhaps not because it is rare, but because it reminds us of scale. Numbers whisper more than they speak. It reminds us that the solar system is not isolated, that Earth is not enclosed, that matter moves freely between stars. It reminds us that our point of view is temporary. Meaning emerges in that reminder. Space rarely gives us simple answers. There is a temptation to assume that rarity confers importance, that what is uncommon must matter more. Nature does not follow this logic. Common things sustain life. Rare things often pass unnoticed. Importance is not inherent, it is contextual. In human experience, this becomes clear over time. Moments that felt insignificant become meaningful in hindsight. Moments that felt extraordinary fade. Meaning shifts. Silence is also a kind of data. From this perspective, 3I Atlas does not carry meaning by itself. It carries information. Meaning arises when that information intersects with human curiosity. We are meaning-making creatures. We cannot help it. Science, at its best, allows this without confusing it for explanation. Numbers whisper more than they speak. Perhaps the deeper lesson of rarity is not about objects at all. It is about attention, what we notice, what we measure, what we remember. Rarity invites us to slow down, to look more carefully, to ask why something stands out, not because it demands meaning, but because we are inclined to seek it. Space rarely gives us simple answers. As more interstellar objects are discovered, 3i Atlas may lose its sense of novelty. It will become one data point among many. Its rarity will diminish statistically, but the question it raises will remain. Does something need to be rare to matter? Or does it matter because we chose to look? Silence is also a kind of data. In the end, rarity is not a verdict. It is a momentary alignment between existence and awareness. 3i Atlas existed long before we noticed it. It will continue long after. Its passage through our attention was brief, and perhaps that is enough. Because meaning does not need to be permanent, it only needs to be present. And in that brief crossing between motion and observation, we find a quiet space where science and reflection meet, without conclusion, without urgency, and without the need to place ourselves at the center of the story. As 3i Atlas continues its quiet passage, it does not slow for us. It does not change course. It does not respond to the attention it briefly receives. Soon it will move beyond the reach of our instruments. Its light will fade into background noise. Its presence will be reduced to data points, graphs, and archived observations. From the universe's perspective, nothing significant will have happened. And yet, from ours, something already has. Space rarely gives us simple answers. Throughout this story, we have asked what makes an object like 3i Atlas rare. We have spoken about probability, geometry, chemistry, timing, and detection. We have seen that rarity is not a single quality, but a convergence of conditions, a narrow overlap between motion and awareness. We have also seen something quieter. That rarity alone does not create meaning. Meaning appears when something intersects with human attention. Silence is also a kind of data. For millions, perhaps tens of millions of years, 3i Atlas traveled without observation. No witness marked its passing. No record acknowledged its existence. And during all that time, it was no less real. The universe does not require recognition. It does not depend on interpretation. It unfolds according to physical laws, indifferent to whether anyone is watching. Humans, however, live differently. We live inside time. We measure it. We feel it pass. We search within it for significance. Numbers whisper more than they speak. When an interstellar object enters our awareness, it briefly bridges these two modes of existence. The timeless motion of the cosmos meets the limited span of human attention. That meeting does not make the object important. It makes the moment reflective. Perhaps that is why discoveries like 3i Atlas linger in the mind. Not because they change the world, but because they adjust perspective. They remind us that Earth is not enclosed, that the solar system is not isolated. That matter moves freely, without regard for our narratives. They remind us that we are not at the center, not spatially, not temporally, not cosmically. Space rarely gives us simple answers. And yet this realization does not diminish human experience. It refines it. To know that we are not central is not to become insignificant. It is to become proportionate. Our lives unfold within a vast structure that neither favors nor ignores us. It simply exists. Meaning, then, is not granted by the universe. It is shaped within us. Silence is also a kind of data. 3i Atlas does not carry a message. It does not symbolize intention or warning. It does not ask to be interpreted. It simply passes through, and in that passing, it offers something subtle. A pause, a reminder of scale, a moment to notice how small alignments can bring distant realities briefly into focus. Soon, attention will shift elsewhere. New objects will be detected. New questions will be asked. 3i Atlas will become one entry among many. But the perspective it encourages does not need to be rare to matter. It only needs to be remembered that we live inside time while the universe moves through it. That observation is brief, but awareness can be deep, and that sometimes the most lasting impact of a discovery is not what it tells us about space, but what it quietly reveals about our place within it. With no conclusion to force and no urgency to resolve, the story of Three-Eye Atlas returns to silence, not as an ending, but as a continuation.